ssh-keycan known hosts automation usually shows up after a bad deploy. A new runner connects to a new server. SSH asks, "Are you sure you want to continue connecting?" And somebody fixes the pipeline by disabling checking or typing yes into a place they cannot verify. Now automation trusts whatever answered first. Maybe it was the right host, maybe DNS was stale, maybe a load balancer pointed at the wrong machine. Today we pin the fleet properly, collect host keys, verify them outside that first SSH connection, and ship known hosts as managed configuration. A host key is the server's long-term SSH identity. User keys answer, "May this person log in?" Host keys answer, "Is this really the server I meant to reach?" On one laptop, OpenSSH stores that answer in your UserKnownHostsFile after the first connection. At fleet scale, first use prompts are not a plan. Build systems, Ansible controllers, backup jobs, and emergency scripts need the same answer every time. So we generate a known hosts file from inventory. Verify the fingerprints through a separate trusted path, and point automation at that file with strict checking turned on. ssh-keyscan is a collector, not a verifier. It opens an SSH transport far enough to receive the server's public host key, then prints known hosts formatted lines. It does not authenticate the server. It does not know whether DNS was correct. It does not know whether a maintenance window replaced a box. That is why the workflow has two halves. Machines can collect quickly from inventory. Humans or a trusted control plane verify the resulting fingerprints against console access, build records, cloud metadata you trust, signed documentation, or your configuration database. After that, clients enforce the pins. Here is the small version. First, create a place for project host key material. Then run ssh-keyscan with a 5-second timeout and request the ed25519 host key. We write it to a generated known hosts file. The name here is short for the card, but use a clearer name in real projects. Next, print the SHA-256 fingerprint with ssh-keygen-l-f and compare that fingerprint out of band. The config block says, for this host, use this project known hosts file and require strict checking. Save that block in a project SSH config and run SSH with -f pointing at it. In a real environment, start from inventory, not from memory. Export hostnames from Terraform, your CMDB, or the source that creates servers. Feed that list to ssh-keyscan, usually with -t for timeout, and -t ed2519, unless you intentionally support other host key types. Sort and deduplicate the output, then produce known hosts gen as a build artifact. Review the fingerprints against a trusted source before promotion. Once approved, ship that file with the deployment tooling or install it through configuration management. Production jobs then use StrictHostKeyChecking yes and UserKnownHostsFile pointing at the generated file. The biggest mistake is treating ssh-keyscan output as trusted because it looks official. It is just what answered on the network at collection time. The second mistake is leaving StrictHostKeyChecking except new in production. Except new, available in modern OpenSSH, automatically records unknown hosts but still rejects changed keys. That makes it useful for a controlled first bootstrap, not for steady-state automation. In production, use yes. If a host key changes, stop the line. Confirm rebuild, rotation, compromise response, or DNS error, then regenerate and republish. Do not train operators to delete warnings until SSH becomes quiet. For non-standard ports, remember known hosts uses bracketed host and port entries. This topic sits between basic SSH client use and serious fleet operations. Yesterday-level SSH works when one admin accepts one prompt. Practitioner-level SSH removes prompts from production without removing protection. UserKnownHostsFile lets each project carry its own trust roots instead of polluting a person's default known hosts. Later, host certificates can reduce per-host pinning by trusting a host CA, which is cleaner for large dynamic fleets. Update host keys can help add new keys after a trusted connection exists, but it is not a magic replacement for verifying an unexpected changed key. The theme is simple. Automation should be boring because trust decisions were made earlier. Try this on your own machine or a disposable VM. If SSHD is running locally, scan localhost. Otherwise, use a lab VM you administer. Put the result in a temporary known hosts file and print its fingerprint. On the server side, compare it with the public host key under etc SSH. For example, the ed25519 public key. Create a tiny project SSH config using UserKnownHostsFile and StrictHostKeyChecking yes, then connect through that config. Finally, make a copy of the known hosts file and replace the key with a different lab key if you have one. The connection should fail. 3 beats to keep. First, ssh-keyscan is collection, not trust. It saves time, but it does not verify identity by itself. Second, known hosts can be managed like any other generated configuration, built from inventory, reviewed, shipped, and used per project with UserKnownHostsFile. Third, production clients should run with StrictHostKeyChecking yes. Except new belongs in controlled bootstrap, and a changed host key stops the line until someone verifies what changed. This is episode 29 of SSH Mastery, with a new SSH administration and defense episode daily on this channel. Also daily, the ranked CVE brief for patch planning.